We are on air. Okay. So, our homework this week.
Honestly, I had a chance to look over it, but I didn't get quite finished with it.
Okay.
It's a busy weekend for us.
How about you, Teddy?
I have done even I opened the quiz, and I have done both, but I need some help. Maybe you guys can help me. Yeah, I have done both. I went ahead and did the part of the quiz also, which is
okay.
Yeah.
Okay, I haven't done any of the quiz. I just did the homework.
Yeah.
I know we're not supposed to discuss the quiz, so maybe we should just go over the homework and then we'll go offline and discuss the quiz.
Yes.
That works.
Okay. So, Morgan, do you want to lead?
Yeah, I can go ahead and start.
What you have? Yeah.
Okay, so what is a sampling distribution? That is number one, right?
Which one is the preparation or the homework assignment?
Preparation.
Yeah.
Yeah, the preparation, because we have to do something. We're supposed to do something together. Is the preparation?
Yeah, the part 2. Yeah.
So do we just want to jump to part 2, or is that the part you didn't get done?
That's the part that I didn't get done, but I would gladly go through it so I can get a better understanding.
Yeah. Great.
Yeah.
And you are pretty sharp on these statistics, Morgan.
Well, I try.
Yeah. Okay.
So have you cut out your little pieces of paper that says to do?
I didn't see that. Let me see. Is that on?
So basically, what it says. Let me find a. So basically, what it says is you're going to cut all these things out, and then it's going to have you do your own sample where you draw 5 of them, add up the totals, divide by 5, and see what your mean is.
Oh, okay.
And what the exercise actually teaches us is our mean is different than what the graph looks like. But the more times you draw out of it, I just simulated myself. We're supposed to ask me, and we're supposed to ask you, and Shelby, and what we all got, and then if we what everybody else got, meaning more samples.
Okay.
Oh, okay.
I see what you're saying. So if it's a sample, if you're only pulling like 5 or 6, you're not going to get as close. Exactly. But as you start getting more, you're going to get closer to that mean.
That's exactly right, and that's what I found is because I just kept doing it a couple times, and I just got closer and closer to that graph, to the center of the graph, the more I did.
Okay.
Oh, really? I did once, but it was almost, I got almost to the center of the, but I did once. I did this morning at 4. Do you want that we go through the first question, Morgan?
We can do whatever. So we're starting part 2, so number 7, correct? And that's the part that we just talked about.
Yeah.
Okay.
Right. So you just write down your sample mean, the mean of your sample.
Okay.
And then you ask 3 other people what they got.
Okay. I'm just going to randomly select 5 and do it just real fast.
Yeah. And how much you got, Mr. Michel?
My mean of my sample was 42,400.
Yeah. My mean was 46,310. 46,300. 10.
310.
Yeah.
Okay. Here's yours, Morgan.
Yeah, right now.
I need my calculator. I'm gonna have to run and get my calculator. My son was borrowing it. I'll be right back.
Oh, okay.
Oh no.
I'm gonna go grab a piece of paper and a pencil real quick, Petty. I work better.
Yeah, that's fine. I need to go to. Yes.
Okay, we'll be right back.
Hey, Shelby.
Hi, sorry.
Oh, you're okay. We just barely started. We just barely started part 2. Cut out your pieces of paper.
What was that?
Did you cut out your pieces of paper for part 2?
I didn't put it up. I just got off work, so I haven't honestly even really gone through it.
Okay. I'll just tell you what I told Morgan. So you have a piece of paper. It looks like this.
Uh-huh.
And what you'll do is you'll cut these all out, and then you'll randomly draw 5 pieces of paper, add up the total, and divide it by 5. What this shows us is if we just do it by ourselves, we don't really come to the center of the graph that it shows you until we start drawing more samples. And then we ask each other what we got for the samples, and then we see that it's actually closer to the mean, the real mean, as we ask everyone else.
Okay.
Hi, Shelby.
Hi.
Hi.
All right, so I got 42,620.
Okay.
Hey, monster.
Just kind of.
And you got 46,610. Yeah, you're close.
What'd you get, Michelle?
I got 42,400.
Okay.
Let me just check it out.
Okay, let's go put you over here real quick. Here, let's take your snake. Say bye. Say bye.
Hi, Lucia.
Oh, now you want to stay? Okay.
Yeah, that's like kind of like I guarantee they want.
Okay, I got 48,500.
48,000. One more time.
48560.
Okay. So if you take 48,960 plus 46,000 plus 46,620, plus 42,400. Ah, dang it, I was doing that. My calculator was off. Second. One, two, three. So there's 4 of us, right? 1, 2, 3, 4. The average is what? That can't be right. Hold on. 42.
What are all the
400.
numbers, Michelle?
Okay, I'll do them again. So 42,400 plus 48,960. Was that what yours was? 48,960?
560.
48,560 plus petty, which is 46,310 plus Morgan 42,620. Divide that by 4 is 44,972. So about 45,000. 45,000. So that's getting closer to the mean.
Closer to the mean. Yeah.
So the more samples, it's just an example of the more samples we have, the closer we will be to the mean, which is, remember which rule that is? I think it's the law of large numbers.
Yeah. The law of large numbers, yes.
I love seeing your lips move, Morgan. We can't hear you. I know you're doing that on purpose.
Law of large numbers. I just know that you'll hear a lot of singing if I have it not on mute.
So for C, I put, it says, does your sample mean appear to be unusual? Explain why you think it is or is not. I put mine appears to be less if I just did my own because I only drew out 5 salaries. But with all of us, it becomes to be a more normal shape because we have different samples, more samples.
You're going to get close to the mean if you have 20 samples versus 5.
Right, right. And then the shape of the distribution is normal.
Normally, yes.
And we know this because the parent population being it's normally distributed. I'm on number 8, I'm sorry.
Nope, you're fine.
Yes.
So the parent population, wouldn't that be, that's the mean of 529. And then C is what is the mean? What is the mean of the sampling distribution of sample mean scores for all such samples?
That's
Sampling mean
five-
is equal to the parent, which is 529.
529. Yeah.
And then standard deviation.
Of the sampling.
35.734.
Yes.
Yep.
Is that what you guys got?
Yeah.
So that's
Okay.
I am
Okay.
tired.
Shelby, did you do the homework, or is this fresh for you?
I read over the homework, but it still hasn't like quite sunk in yet because I kind of read it as I was working.
Okay.
But so it's new work. I haven't quite taken the time I need to with it.
Okay. I guess I'm just asking because I don't want to like overtake,
No, you're-
overtake the situation. If you guys, Morgan, if you want to take it, or Petty, or.
Okay.
Oh, you're good.
Yeah.
Fine.
I think
Want me to
if you
go
have,
ahead?
yeah, keep going ahead. You're good.
Yeah.
Okay. Okay, so if we go to the homework assignment number 1, what's the difference between the central limit theorem and the law of large numbers? What I did is how it was easier for me to remember this, because the central limit theorem has to do with the shape of the distribution. I'll see if I can draw this out. This helped me if we think of the acronym CLT, the central limit theorem, can you guys see that?
I cannot see it.
Can you see that if I put that up there? Let me do this. CLT, do you see this?
Yeah.
Yeah.
As we add more, see how I'm going to be making a pyramid here. CLT, CLT, CLT.
You lost her.
Michelle,
I think she disconnected.
yeah, she's frozen.
Yeah, he got her a cat. No, you're my favorite plant.
Maybe I'll text her and see if she can get
That
that.
would be great.
Okay. Oh, it says she left the group chat.
We'll do that.
So.
There is a fly in here. I'm gonna go crazy.
Jabba jaw.
Morgan,
Yes.
a question.
Okay.
Look, in this part, in the last question of the last exercise, for
Okay.
example, here this number it got 35.733333. But then when I went to the answer sheet, it says 35.734. Why they rounded if was no more than 5?
I'm not sure why they would have rounded up.
Yeah.
Normally, if it's below, like I said before,
Below 5.
You just leave it normal. But if it's above 5, you go up.
Yeah.
I thought that maybe.
Yeah, and I got that, and then I saw about you asking about this, because you know how much I struggle with that.
Yeah.
But I thought maybe it's a rule that I don't know or something. Well, yeah.
Yeah, I don't know why they did it that way. I mean, it could be any reason. Hey, let's not drown yourself.
Is she coming back?
Just gonna see if I can.
Should we call her? Are you there? What? I don't have the phone number here.
I don't know how to add her back into the
group thing.
Is she showing? No.
Oh, she just sent me a message. Oh, she said her internet is not working.
Mm. Oh, oh.
Okay.
I'm
Oh.
trying to figure out what's happening and she'll join on when she can. Oh, she's here.
There you are.
My husband. I don't know what happened. Anyway, okay, what'd you guys figure out? Are you just waiting for me?
Yeah.
No, we're just worried.
Yeah, we haven't done anything.
Okay. So what I was saying was is the central theorem, the central limit theorem. The way to remember it is if it just stacks out like a pyramid, the more samples you get, it stays evenly distributed. It has to be the same. Does that make sense?
Okay. With that, you prove that the shape will be affected. Is that right?
Right.
That's what you want to prove.
Right.
Okay. And I remember
The law
that.
of large numbers. The law of large numbers describes the spread of the distribution of the sample means.
Yeah.
Number 2, which of the following gives the best explanation of the law of large numbers? If the sample size is large, the sample mean will be close to the population mean.
Yes. That's the second. Is that right? C. Yes.
C.
C.
Yes. The third.
And then the third, what was the shape of the distribution of the sample mean?
I got the A, skewed right.
It's skewed right, but I think the reason why is
the reason
because
is because that is because the standard deviation is less than 30. No.
I think it's
the sample it was only 4 and needs to be more than 30.
right.
Mm-hmm.
But it said there was something that I found that talked about the skew. It said something had to happen. I can't remember. I wanted to see what you guys said about it, what your input was with it. Oh, here it says right here.
I found this in the notes when it says here for most moderately skewed distribution, a sample size of around 30 is traditional, so to be sufficiently large to assure that X will be approximately normally distributed.
Yes.
Yeah, that because of that, I know I need to look for that number to be sure to answer, because it can be tricky, you know.
Right.
Sometimes it is skewed right, but you need to look not only at that, but also at the number of the sample to know that it's more than 30. Mm-hmm.
Right.
Yeah.
That's on 3.1. It says for most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure that the sample, that the sample mean will be approximately normally distributed.
Yes.
It's not a definite number, but there's a rule of.
But it's a rule of thumb. Yeah.
So this one tells us it's skewed right, and there isn't very many people in the sample. Or I'm sorry, the. So that's why I think it stays.
What was that? Sorry, you cut out. It went.
I said because the standard deviation is small, and if it tells us it's skewed right, and if the standard deviation is small, it stays skewed right.
Okay.
Is that how you understand it, Petty?
Yes. I follow the rule and it's effective. I got that fine.
Okay.
So then number 4 is, what was the mean of the distribution of the sample mean?
30.
And
30.
that's 30 because that's one of the rules. It says,
I'll be right back, guys. I'm gonna go drop her off.
okay. I want to be able to find the rule so I can tell you.
Yeah.
Okay, it says the mean of the sample mean is mu. Okay. The mean of the sample means was always aligned with mu. Okay. If the parent population is normal, the distribution of the sample mean, sample size n. Even if the parent population is not normal, the central limit theorem guarantees that the distribution of the sample mean will be approximately normal if the sample size n is large enough.
Yes.
So when it tells us what the sample is, what the mean is of the distribution, it's the sample. It's the same.
Mm-hmm.
And then it tells us what the standard deviation was for that, which was, oh, I'm sorry. This is where you do your formula.
And
do you know how to do your formula?
You do. That I fail, but then I realize is the omega over root for the number. Is that right? The formula.
You take it says that you take so you want to take the deviation.
Yeah.
And you want to divide it by the square root of the sample.
Yeah.
So you take the
How much you got it?
I got 2.
2?
2.
Yeah. I got different.
Hetty, how did you do it?
I applying the formula. I do the standard deviation, which is 4 over the root for the population, and the sample is 4 students. Is that right? And then that's the result.
4 divided
Is that right?
by the root of 4.
Divided, yes. And then I got the result.
What did you get?
Ay, caramba. Okay. 4 divided by root of 4. 4 divided by 2.
Yeah.
2.
Yeah.
2. Yeah, in the morning I was doing a crazy thing. I got 15, and it was not right. It's 2. It was 4 in the morning. Yeah.
Yeah. I would probably have something different if I did it at 4 in the morning.
that was my only option because I needed to come to work at 7. Yeah.
Okay, so if we go to number 6, because the sample, because the mean is 30, and because the sample is 100, it's large.
Yeah.
We know that it's going to be normally distributed.
Did you read the question, guys?
Yes.
Okay.
Do you have it?
Yes. And yes, I agree with Michelle because I look at again to the random sample. The sample is 100, which means it's more than 30. That will tell me that it's normal. Although it says that the distribution is right skewed. That's the rule.
Yeah, so the answer is
No,
not right skewed.
It's
I put
normal.
B. I put normal.
Normal is normal. B.
Okay.
I was just reasoning, I mean, supporting my answer.
Oh, I
It's
see.
Oh, okay.
B, normal. Yes.
Okay.
7.
And then for number 7, the mean of the distribution is 30.
Yes.
That was given to us.
Yeah.
So now the standard deviation, we take the standard deviation, which is 4,
Yes.
and we divide it by the square root of 100. Do you understand that, Shelby?
No, I didn't follow you there.
I got another. Can you explain that, Michelle? Because I got different and it was wrong. Can you explain that?
Sure. So in the question above number 6, for number 6 through 8, it tells us already that the mean is 30.
Mm-hmm.
Yeah.
So we got that for number 7.
Yes.
For number 8, this is a formula. It's a formula that we have to know. And the formula is you take the standard deviation that they give to you, which is 4. And you're going to divide that by the sample, the square root of the sample.
Yes.
And so I got 0.4 hours.
So I think I did it wrong. I missed this part where I need to do it by the square root of the sample.
Mm-hmm.
Yeah, the formula is applied many times. I mean, for almost everything is 4 root 100 equal. Why I get? No.
I got point.
No. I am doing wrong. I am doing wrong. I know what I'm doing wrong. 30 divided.
Are you using a
4.
scientific calculator?
Yeah. Well, kind of. My daughters criticize me, but I got 75 all the time. But this is.
Find the square root of 100. That's the first thing you want. If it gets confusing, find the square root of 100.
Yeah, because I got
Which
75.
is 10.
Yeah.
Because
It's
10
10.
times 10 is 100.
It's 10. Then I divided.
It's 10.
Mm-hmm.
Divided by 4.
4 divided by 10.
0.4.
Yep, that's your answer. Okay. And you get it 0.4. Is that right?
Right.
Yeah.
Okay, so then number 9. What's the shape of the, number 9. The length of human pregnancies from conception to birth is normally distributed with mean 266 and a standard deviation of 16 days. Suppose a random sample of 30 pregnancies was measured. Use this information 9 through 13. So the shape of the distribution, we have 30 samples.
B.
So that is considered normal.
Normal. B. Normal.
Normal.
Mm-hmm. What was
So
the
the mean? So that was
200
given to us. That's 266.
266.
And now we take the standard deviation, which is 16. Divide that by the square root of 30.
Yes. And it's 2.921. Is that
Yes.
right?
That's what I
Okay.
got.
That's what, yeah.
And it says, is the mean of the distribution of means greater than, equal to, or less than the parent population? So the mean of the distribution is 266. This is also
Equal.
the parent population.
Is equal. Is equal.
Yeah.
That's what I put as equal.
Yeah.
Is the standard deviation greater than?
And this is a rule that was in the homework. It says, is the standard deviation of the distribution means greater than, equal to, or less than the parent population standard deviation? So this is kind of a rule that it says if the standard is that it just that it will be less than. I mean, and you can see up in the so deviation is 16 days. You know that you're taking that 16 and you're dividing it by the square root than what it was before.
Dividing it by the square root of what it was before, is that what you said?
Dividing it by something else, dividing it by the square root of something else, and less, because you're dividing it.
Okay. Okay.
Out square root of anything. If you take 10, if we're trying to find the standard deviation, let's take a fraction, a really easy fraction. Take 10 and divide it by 2. What's the answer? 5. Is 5 less than 10? Yes.
Okay.
Same thing. We're going to take the standard deviation of 16 and we're going to divide it by something else, its square root. It's obvious that the new standard deviation will be smaller than the original one.
Okay. Okay. I'm following you now.
Not only do we have to do this math, we have to learn a new language.
Seriously.
Yes. Third language. Fourth language.
Okay.
For me it's a torture. Okay.
Your own words, what the central limit theorem is. We kind of talked about that. As the sample sizes increases, it's approximately normal.
The shape. Yeah.
And the law of large numbers, as the sample size increases, the sample mean will be closer to the population mean.
Mm-hmm. Okay.
All right.
All right. The test is. Huh?
So are we ready to do the quiz?
I think is the quiz is less than this.
Okay, so which of the following is the best statement of the law of large numbers?
Yeah.
Am I on the right one?
Number 6. Lesson home. You go to the homework, right?
Yeah.
But you haven't started the quiz? Have you
Isn't that what
started?
we want to do?
Mine says when taking samples of n when n is equal to 5, what is the shape of the distribution? Is that not what yours says?
I may have gone to the wrong one. I went to the
Mine says when taking samples of n when n equals 5, what was the shape of the distribution of means histogram?
So did you guys 6:30 or did you guys?
I have a question. Where are you guys? You're not in the quiz, number 3?
Yes.
Yeah, that's
Huh?
6,
What?
right?
Number 3.
Yes, Betty, yes. We're number 3.
Okay.
Is about, did you guys take out some slides? You run without slides? We need slides.
Taking samples again when it equals 5, what was the shape of the distribution of histogram when the parent population is right skewed?
Michelle, I cannot hear you well.
Either.
I think Morgan,
yes.
because we listen background from you, I think.
You hear
That
my background?
overpowers Michelle. Yeah. Thank you. Michelle, now number 3.
So this has to do with the histogram that we saw. If you do if we did the homework, if you went through the reading material, let's see if I can. I need to pull over to a different screen because I can. Let's see here. I need to pull this over to a different screen. I wonder if I can.
Okay.
So let me here.
If
we go into the homework.
Hello, hi. I answered skewed right. I will tell you why. When taking samples of n, when n is 5, okay, what was the shape of the distribution of means histogram when the parent population is right skewed? And since they are giving me that n is 5, is less than 30, will be right skewed. Is that right?
Yes.
Okay.
There is a place to go to the applet. We went to an applet. It was a different applet. Do you remember?
Oh, yeah.
We went to that different applet and we kind of played around on it.
No, that one with the, I didn't do none of those.
But that tells us, here we go. So 5, yeah. So it is right skewed. Let me see here.
It's right. Yeah, I did without looking at because of the rule. Is that right? Yeah.
Right.
So it's
yeah. And number 4.
So when taking samples n equals 100, what was the shape of the distribution means histogram when the parent population is right skewed? Isn't that normal?
Normal. That's the answer.
When taking samples of n equals 100, what was the shape of the distribution means histogram where the parent population is normally distributed?
What do you think? I put normal, but what do you think?
I think it should be normal.
Normal, yes.
When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. Not that one, I don't think. Data are drawn from a population that is normally distributed and the sample size is large. I think that one.
That one, yes.
Data are drawn from a population that is right skewed and the sample size is small. No. Data are drawn from a population that is right skewed and the sample size is large. I think that one.
Yeah.
How many you got? 2?
Yeah.
And the first one, why is not? Because I did that. Data are drawn from a population that is normally distributed.
Distributed.
And distributed, thank you. And the sample size is small.
Right. You don't. It's not going to.
But it's normal. Distributed.
Yeah. Yeah.
Distributed.
So it has to be the second one and the fourth one.
Huh?
I just said the second one and the fourth one.
Yeah, but not the first one. You
No.
don't think that? No. Okay.
Because the sample, if it's normally distributed and the sample size is small.
Who cares? I mean, sorry.
Oh, that's right. That's right.
Yes, because when it's right skew is when you need to care about the amount of the population. See, if it's more than 30, then it's normal.
Because
Is
I
that
think
right?
Okay, let me look here.
That's what you're saying.
Because this is normal distributed. You don't care about the amount if it's small or large.
Right. It says if the parent population is normal, the distribution of the sample means will be normal for every sample size.
Correct. Correct.
Yep. For every sample size.
Yes. Entonces will be the first, the second, and the fourth. Is that right?
I think so.
Okay. Me too. That's that.
Yes. I'm glad you brought that up. Thank you, Petty.
Yeah.
Morgan, do you need us to go back to the other one and explain how we got it?
I muted you, Trey.
Couldn't get my unmute button. I'm good. It's all right. I'm gonna go through and read it again real quick.
Okay. Okay.
Okay. So then the next one, number 7, which of the following gives the best explanation of the central limit theorem?
I answered the last one. What do you think?
That's what I think.
The last one. I will tell you why. Because in the last one they consider the shape, and another is another tip from the words. It says approximate. Help me with this pronunciation. Approximately normal.
Yeah,
Right.
you did it.
Yeah. And that's the only option that has those two.
Right.
I think.
Oh, I see.
Mhm.
Okay.
Mm-hmm.
Okay, so number 8, let x be a random variable with a population mean of 10 and population standard deviation of 6. Suppose the sample size n equals 36 is a draw from this population. What is the mean of the distribution of the sample means? Wouldn't that be 10?
10 is too simple. That is, yeah,
Yeah.
10.
No.
Do you agree?
What is? Yes, I agree.
You guys, Shelby, Morgan?
Yeah, 10.
Yeah, 10. Okay.
What is the standard deviation of the distribution of sample means? So now we're going to take the standard deviation,
Okay.
the population standard deviation, which is 6, right?
Yeah.
Right.
We're going to divide that by the square root of 36.
36. How much you got?
Well, it should be 1.
Me too, but you know what? I didn't. Because they put 3 decimal places, I thought maybe I'm not right. But it's 1. I got 1 too.
Well, let me go back and let's just make sure. Let's just kind of look at the same type of question.
So did you just put 1 or did you put the 1.8171?
It should just be 1, but we could do 1.000.
And what did I do wrong here?
Yeah, I got 1, solid 1. without any decimal.
Oh, I hit the wrong button.
I was going to say the square root of 36 is 6, and so divided by 6 is 1.
It's 1.
Right. But since it wants 3 decimal places, should we put 1 row?
Oh, it does.
Yeah, I will.
1.0.
If it likes it or not.
3 zeros?
Because it says 3 decimal places.
That's what it threw me. I thought I was doing wrong.
I'll put the 3 zeros and submit it and let you guys know.
Because I think that's what it should be.
I do too.
Regardless of the distribution of the population, if the sample size is large, greater than 30, what would be the shape of the distribution of the sample? The sample size is large. Shouldn't it be normal?
Yes.
If it's over 30.
Yes. What theorem would justify your response to number 10? Shouldn't it be the law of large numbers? Sorry. Yeah.
But they are talking about the shape, not the spread. The question is, what could be the shape of the distribution of the sample mean?
Well, the shape, remember the central limit theorem is describing the shape.
Yes. Is that right?
Yeah.
Because that's why I didn't put large numbers.
Yeah, because the shape, what would be the shape?
Because the question is, what would be the shape of the distribution of the sample mean? O sea,
Yeah.
to do this, which theorem we use will be the...
Yeah, I
Is that
submitted
right?
it. It does want the 3 zeros, and it is the central theorem.
Yeah.
Yes. Okay. And what is the answer with 1.00 or not?
Yep, 1 point. Yep, it wants. I put the zeros, and it made it correct.
It's
Okay.
3 zeros, correct.
Right.
Okay.
3 zeros.
Okay. The 11 is central.
Yes.
Okay. Yeah, I was. Yeah.
Yeah.
Okay. For me, it's my second time.
Morgan, do you need us to go through those? Did you get those?
Yeah.
Let me read back what I got here for the answers.
Okay.
So I got, hold on a second, lost it. Hey, you. So I got true, true. On number 3, I got skewed right. Number 4, I got normal.
Yes.
Number 5, I got normal.
Yes.
Okay, number 6, I got 1, 2, and 4.
Yes.
Number 7, I got D. If the sample size is large, the shape of the sampling is normal. 8 is 10. 9, I got 1.000. 10, I got normal, and then 11, I got central limit theorem.
Yep.
Okay.
I think that's. Oh, we weren't supposed to talk about that online. Oops.
Oh.